Hey guys, welcome to another unique path problem, which is 2D We have started it yesterday. And if you haven't seen unique path 1, please go to the previous video and see that video. You can check for that on the I button here. And so let's do this question. The question is very similar to the last one, that we have to move from 0, comma 0 to m minus 1, comma n minus 1. Here we are given grid, so we will be going from grid dot size minus 1 to grid dot 0 dot size minus 1. It is like grid of m minus 1 to n minus 1 only. Fine. And we can move right and downside only. So there, the only difference is that we are got an X obstacle over here. If there is an obstacle, we cannot go to that position. So this means that if we reach this point, we have to move back. So if we check the question, this is one of the test case and it will explain it very well. So when you check this point, we have to move from this point to this point. Fine. So the first direction that comes to my mind is right, right, down, down. So this will be my one way. Fine. Another will be right, down, down, right, right. So this will be my another way. And all other possible ways are if I come to this point and again go to center, which is not possible. And similarly from this side as well. So only possible ways will be two. Only thing to know here is that there will be one extra if condition, which is if grid of I comma j is equal to 1, we have to return 0. We have to return from that field. Fine. So let's type the conditions. So it will be first of all solve I comma j comma grid only. We will be using grid size again and again. So I'll just write it down. Grid dot size comma n equal to grid of 0 dot size. Okay, this must be known to you all. Yeah, I'm just writing down the size. That is nothing else. Fine. So if I is greater than m minus 1 or j is greater than n minus 1, or the new condition I'm adding only here is grid of I j. It is 1 only, so I need not to check for that. I'll return 0. And the another condition will be okay. And another condition will be if I equal to m minus 1 and j equal to n minus 1, return 1. And we can say right side is equal to solve of I comma j plus 1. We have to include right side. And left equal to solve of, sorry, left, it if we are not going left side, if we are going downside, down equal to solve of I plus 1 comma j comma grid. And we have to return all possible parts, so return right plus of down. I guess this does the work. And this will be your whole code. Explaining it once again, this is a recursive calls. So these are the size, like this is the size of the, we can say, row, and this is the size of the column. M column and n rows, M cross n. And if I is greater than m minus 1, means it crosses this side, or j is greater than n minus 1, it crosses this side, or grid of ij, which shows that if it is 1, then we will return 0. Then we will return 0. If I equal to m minus 1 and j equal to n minus 1, means we have reached this point, we'll return 1. Okay, and rest is the recursive calls, which is right is equal to I j plus 1, means we are moving this side, and down I plus 1, which means we are going this side. That's it, and we're returning, adding them both. So if I code this problem, it will be solve of 0 comma 0 of it. You know what the problem is? I will not be able to type this big again and again, so I'll just rename it here only, and I'll be returning it directly. So I have no constraint. Int of solve, int of I comma int of j comma vector of vector int and of grid. And when you open this, so very first condition, if I is greater than m minus 1 or j is greater than n minus 1, or or We can say grid of I j return 0. Fine. Now I haven't declared m and n, so I'll be declaring it here. Is equal to grid dot size, comma n equal to grid of 0 dot size. Yeah, and that's it. And the right equal to right equal to solve of I plus sorry I comma j plus 1. We are going right side, and int down equal to I plus 1 comma j comma grid. And what we have to return right plus down is this the best case. What the problem is here now? Okay, so I haven't counted the paths. I missed one condition, which is very very important. That will give us the result. Uh, return on. Like if we reach this point, I have missed that condition while I was writing this. So yeah, it is accepted. But you know what will happen if I submit it? Time limit exceeded for sure. Because the test cases are going till 100, and 2 raised to power 100 is a very big number. So what we have to do, again we'll use a 2D vector which we'll name as dp, and what size it should be, grid dot size for the columns, and for the uh, rows I'll keep it as maximum as I can. So grid of 0 dot size, and I'll give it minus. And you know what I have to do now. Just go into it, type dp, all calls, type dp, add here a dp. I'll just copy this one half part and add dp here. Fine. And when we go down, dp of I j equal to this. If dp of I j not equal to minus 1, return dp of I j. Okay, if you have to check that this test case pass, like you don't want an extra submission for that. You know, some people are like very submission conscious. Like they like to submit the very perfect solution each and every time. So just add this test case from this place, and you will see it here. Case 5, it has passed now. So this means that the code will execute successfully, and yeah, beats 100%. And I don't know if I will be able to analyze the complexity. No, fine. It will go for O of n square again. Fine, because we are using 2DDP. And I guess that's it with the question. I'll explain the recursive code again. It is very same as the last video's one. Only thing I have changed that I have added one more or condition. If grid of ij will be 1, then I will again returning 0. Okay, my PC is gonna be dead. So thanks, and if any query you can ask in comment section. Like, subscribe, and share again. That's it. Wish you a nice day.